Today we're going to be learning about volume, and we're going to focus today on the volume of prisms and cylinders. Both of these figures have two bases. So let's start by talking about what these figures are. I'm going to start by talking about prisms. Prisms are referred to as polyhedra, that's plural, polyhedron would be singular. They're three-dimensional figures, also referred to as solids, and they have flat faces. And they're made up of, the prisms are made up of polygons. All the sides have polygons. So with a prism, all the sides are polygons except the bases. The bases are the two sides that are, all the sides are rectangular, and all the sides are rectangular in a prism except for the two sides that are bases. Those two sides that are bases will be parallel to each other, and they could be a rectangle, a square, or some other type of polygon. So for example, here we have a triangular prism. It has all sides rectangles except for the two sides that have triangles, and those two are called the bases. Bases in a prism are parallel to each other, just like in a polygon, how bases are the opposite sides that are parallel to each other. And with prisms, our prisms are named according to the shape of the base. So this is a triangular prism because the bases are triangles. Here's a pentagonal prism because the bases are pentagons. Now, we also have rectangular prisms. With rectangular prisms, you can't necessarily determine which two sides will be your bases. It doesn't really matter. You just pick two sides that are opposite from each other in parallel and let those two sides be the bases. It doesn't really matter. Okay? We also have figures with only one base, and these are called pyramids. And we'll talk about the volume of pyramids later. But let's just talk about what they are. So pyramids, much like triangles, have a vertex and a side opposite the vertex is perpendicular to it, which is the base. So the base of a pyramid is opposite the vertex, and it's also perpendicular to that vertex. Okay? So, and the pyramids are named according to the shape of the base. So here I have a triangular pyramid. Oops. Here I have a triangular pyramid because the base is a triangle. Here I have a pentagonal prism because the base is a pentagon. So with pyramids you have one base. With prisms you have two bases. Prisms, all the sides are rectangles except the bases. With pyramids, all the sides are triangles except the bases. Prisms have sides or faces that are polygons. Two of the sides are the same shape and parallel to each other, and those are called the bases, like I just mentioned. And they will be parallel, like with two-dimensional figures. The height, just like with two-dimensional figures, is the perpendicular distance between the two parallel bases. So the height is the perpendicular distance between the two parallel bases. Now, you will have multiple heights. You will have the same number of heights as you have sides on your bases. So, notice all the heights I'm drawing. How many heights do we have for our triangular prism? 3 heights, because there's 3 sides to our triangle, which each of the vertexes on the triangle creates a height. What type of prism has all sides congruent? A cube has all sides congruent. It's a prism with all sides congruent. What type of prism or prisms is it impossible to determine which sides are the bases? Rectangular prisms and cubes, you can't really tell which sides are the bases. Square prisms you can, and I'll show you that in a minute. A cube is a type of square prism. But general square prisms you'll be able to tell because you'll have rectangles as the sides and squares as the bases. What is the shape of all the sides, not including the bases, of all prisms? Rectangles. Volume is the amount it takes to fill up an object. For example, how much water or sand would fit inside of something. It is going to be units cubed because we're working in 3 dimensions. It will also be units cubed because we'll be multiplying 3 lengths together. So it takes us into base, height, and width, or you might think of it as length, width, and height from elementary school. We're actually going to think of it as base, height, and height, with those 2 heights being different heights. To find the volume of a prism, you multiply the area of the base times the height of the prism. The area of the base is going to be the area of some polygon. So we're going to use all our formulas to find area of polygons in order to find the area of the base. And then we're going to multiply that times the height of the three-dimensional figure. Again, the height of the three-dimensional figure is going to connect the two bases. It's going to be the perpendicular distance between the two bases, and the two bases will be polygons. So here's the formula, but instead of having a little b, it has a capital B, and that capital B actually has meaning. It means area of base. So let's write that in, area of base. So we find the area of one of the bases, and we multiply it times one of the heights. And that gives us the area of the entire figure, or the entire prism. So here's an example of a cube. And with a cube, it doesn't really matter which sides you let be the bases, because all the bases are squares. So you just pick two sides that are parallel to each other. So I'm going to pick this side, and then, which is the top. It looks like it would be the top. It's not necessarily the top, because I could twist it around. And the bottom, I'll let these two be my bases parallel to each other. So just find the area of one of those, which is 16, and I'll multiply that by the height, which is the perpendicular distance between the two bases. So I'm going to say 16, which is the area of the base, times the area of the height of the entire figure, which is the perpendicular distance between the two bases, and that gives me 64 as my volume. And like I said, it's going to be units cubed because we're working in 3 dimensions. It's how much will fill out this 3-dimensional figure. Also, it's this 4 times this 4 times that 4. You're really multiplying 3 things here, because we did 4 by 4 to get 16. And then we did that by 4. We multiplied that by 4, which is the height, to get 64. When we're looking at some of our different types of prisms, to find the volume, it's always the area of the base times the height of the 3-dimensional figure. So you use your different area formulas. So for example, if we have a rectangular prism, we're going to substitute B times H in the place of capital B to find the area of the base. And you don't have to put parentheses around the B times the H. I just put them there to emphasize that that's the area of the base. Okay? When we're finding the volume for a triangular prism, we're going to find the area of a triangle, which is 1/2 base times height, times the height of the entire figure. Now, one thing I want to make sure you're super duper clear about is the difference between these two H's. See that there's two H's up there? They mean different things. And 1/2 base times height, I'm talking about the perpendicular distance between the vertex and the base. That's the height. That's the perpendicular distance between the vertex and the base of my triangle. Okay, so that's where this height comes from. And this little b, of course, is that side that's across from our vertex. So that's where that little b comes from. Whereas this other h is from our 3-dimensional figure. It's the perpendicular distance between the two bases. With a trapezoidal prism, again, it's the area of the base times the height. So you find the trapezoid formula, you put that in the place of capital B, and you multiply that times the height of the whole thing. So it's 1/2 the sum of the bases times the height of the whole thing. So here we have to find the two bases of our trapezoid, put those in the formula, adding them together. We have to find the height of the trapezoid, which is the perpendicular distance between the two bases. Put that in the place of this h right here that goes with our trapezoid. And then we have to find the height of the entire 3-dimensional figure, which is the perpendicular distance between the two bases of the 3-dimensional figure. Find the volume of each of these figures. So for the first one, we want to find the volume by multiplying base times height of the base. It doesn't matter which side you use to be your base here. So I chose what looks like the bottom right here, and I did 5 times 4 to find 20 to be the area of my base, times 6, which would be the perpendicular distance between my two bases, my two rectangles, which is 6, and I multiply to get 120. It's units cubed. Notice we're multiplying 3 different lengths, and that's another way we get into the 3rd dimension. In the next one, the base is a square. So the formula for a square is s squared. So I'm going to substitute s squared in the place of capital B. So that gives me 3 squared to find the area of my base, which of course is 9. And then the height is the perpendicular distance between the two squares, right here, which was 10. That gives me 90 units cubed. In the last one, they actually give you the area of the base. That's what capital B means, is area of the base. So you don't have to figure out the area of the base. They've already given it to you. So you just substitute 45 in the place of capital B, and you get 450 units cubed. So I substitute everything into my formula, which is the area of the trapezoid times the height of the entire figure. I know the basis because they're given of the trapezoid. I know the height of the trapezoid because it's given. And I know the volume because it's given. And I'm solving for the height of the entire figure. So now I just need to simplify within the bracket. So 1/2, first you add this. You can put it straight into your calculator, actually. You can just put in 0.5, parentheses 2.4 plus 1.6, parentheses 1.2, and it'll give you 2.4 if you put it straight in. So you end up with 12 equals 2.4h. You divide both sides by 2.4 or multiply by the reciprocal, and h equals 5. And we know it's meters because h is height. It's just a length. So it's just meters, not meters squared or meters cubed. The formula for the volume of a cylinder is the exact same as the formula for the volume of a prism. You find the area of the base and you multiply it times the height. It's just the area of the base is pi r squared. So you put that in the place of capital B, and substitute r in the place of r, h in the place of h, and you get your volume. And here are all the steps that I expect to see and the answers. So we know that the volume formula for a circle is area of base times height, which is pi r squared h. So what we're going to do is substitute our information in here and solve for height to begin with. To solve for height, what we're going to do is plug in 12 pi in the place of volume over here, and then we're going to substitute in 4 in the place, or excuse me, 2 in the place of r, so 2 squared is 4. And then we simplify by dividing both sides by 4 pi to get h by itself. And the pi's cancel here, and then the 4's cancel there. And then on the other side, the pi's cancel, and 12 divided by 4 is 3, so h is 3. So the area is 4 pi because we just put 2 in pi r squared, which is the formula for area of a circle, and 2 squared is 4, so it's 4 pi. Try this problem.